Right. So we're looking at 5.3, and yesterday in 5.2, we talked about how to prove triangles congruent. So we prove triangles congruent by the definition of congruent triangles, which was all three pairs of angles are congruent, all three pairs of sides are congruent. That's a lot of information needed. Right? That was 6 pieces of information that we needed to know before we could say the triangles were congruent. So today we're going to find our first shortcut to that. Okay, and then after the quiz, we'll have even more shortcuts to that, how to prove triangles congruent. The one that we're talking about today is called SAS, side angle side. And this was the one theorem that I asked you to copy down. Okay, side angle side, we abbreviate it SAS. So let's take a look at what that actually shows us. All right, what we're trying to do is we're trying to prove that triangles are congruent. So if we have enough information that kind of locks it into place where the two triangles we're talking about have to be the exact same, then that's all we need, right? That's all the information that we need. We don't need all 6. So here is a situation where we have 3 pieces of information, and that's enough to guarantee that these two triangles are going to be the same. We don't have to know the rest of the information. I don't need to know the other 3 pieces. I just need to know these 3. So I need to have 2 pairs of sides that are congruent and what we call the included angle. Okay, the included angle. Okay, I would underline included angle wherever you have it written down. So we need the included angle, and an included angle is the angle that's formed by the 2 sides that we know are congruent. So it's in between the 2 sides. Okay, that is the included angle. So you see here, angle A is the included angle because it's formed by these 2 sides that we know are congruent to these 2 sides. So we have that included angle is the one that's congruent. If it's not the included angle that's congruent, we cannot use SAS. It's called SAS, or side angle side, because that's the order in which we see those pieces of information. Right? In our triangle, we have a side, then then an angle, then a side. Right? On both of these, we have a side, angle, side. If that angle is not in between the 2 sides, we have something else, and that doesn't work. Right? So it's very specific into the order in which we have this information. Now, when we see proofs, it doesn't matter what order the steps come in our proof, as long as we have all 3 pieces of information. So you don't have to state something about the side first, and then the angle, and then the side in our proof. As long as we have all 3 of those pairs, then we can say that the triangles are congruent. So again, this is our first of quite a few theorems that are going to help us prove triangles congruent. Now that we know these, it's going to be very rare that we're ever going to use the definition of congruent triangles, because that's going to be twice as much work as our theorems are. Okay. So we got side, angle, side. Okay, tell the person next to you, why is it called side, angle, side? Why is that important? So I want to look just for a minute here at why this works, why this is enough information, right? If I have the side, the angle, and the side are the exact same in both. Really, the only thing that's missing that we have no information about is that 3rd side, right? But with the fact that we know these side lengths, so this has to end here, this has to end here, and it has to have this angle, it is guaranteed to end here and here. We can't extend either one of these. We can't make it wider, shorter, or anything like that. It's guaranteed. It is locked in for both of those sides to end here and here. And all we have to do, or all we can do, is connect them. It's the same thing over here. You got the same length, the same angle. It's guaranteed to be there. We cannot create a different triangle out of that. All right, those three pieces of information, there is only one triangle that I can form, which is why that's enough to prove for sure that those are going to be congruent. So we're going to look at a proof first today. Okay, we'll look at a few of them, or at least more than one. Because really that's, I mean, SAS, that's the only thing that we're learning about today. That's the one thing. So now we got to use it. So here's our picture. Here's what we're trying to prove. Let's talk this one through together, and then later on I'll have you do some on your own. But remember, we need two pairs of sides. We need the included angle to be congruent. They give us one of those sides. So they give us BC is congruent to DA. We know that's given. That's already marked up here. Those are congruent. Okay, I need another pair of sides, and I need an included angle. What other pair of sides could I say are congruent? Addie?
CA and AC.
CA and AC. And what's the reason there, Addie?
Reflexive.
There you go. CA and AC, that is reflexive because they are the same exact line. They're the same segment. Right, typically when we mark it up, we're just going to put, the two tick marks there. Even though it doesn't have a match anywhere else, right? That's the only place where I've got those two tick marks. That's telling me, all right, I used this segment. I used that side. So I mark it up so that I know, hey, I got that. I already said that side is congruent. Notice Addie said it exactly right, ACCA, because they're in a different order here and here, right? And we got to follow that. We got to follow that congruent statement we talked about yesterday. So we've got two pairs of sides. We need the included angle. So I want you to point out to the person next to you, where are those included angles located? Look at one triangle at a time.
Yeah.
Okay. So what angles are we talking about? Which angles are going to be those included angles here? Ethan? BCA and DAC. Those are going to be my included angles. So we need to be able to say that those are congruent to each other. So we need to be able to say that BCA is congruent to DAC. What's the reason? Why can we say that those angles are congruent? Right? Yeah, it's alternate interior. Anytime, guys, anytime you see parallel lines, if they give you the fact that lines are parallel, we need to be on the lookout for AIA. And if we look at those parallel lines form that Z shape, right, with those two angles. So with that Z shape, that is alternate interior angles. So now we have what we needed. We needed two sides, the included angle. You don't have to write the S and the S and the A. I'm doing that just to point out we have enough information. Sometimes that's helpful. Sometimes you might want to do that. Okay, so to keep track of what information I actually set. So we got side, angle, side. That's enough then to say triangle ABC is congruent to triangle CDA. And what's our reason here? SAS. Side, angle, side. Okay, a little bit shorter than yesterday's. Okay, a little bit less stuff. We just got to make sure we got those included angles. Okay. Any questions about this one as we walk through it? Okay. We'll come back to a proof. I just want to look real quick here at something else that's not a proof. We could make it a proof. We're not going to. So I want you to talk to somebody. Do we have enough information here to prove that these two triangles are congruent? Do we have enough information for the triangles are congruent? Talk someone.
No. Yeah.
What information do we know for sure? Here, what can you tell me that you're pretty confident that you can tell me this is true?
It's the midpoint of X, Q, and R.
Okay, why is that the midpoint? Center of the circle, right? All radii are congruent in a circle. So that means not only is M the midpoint, that means that these have to be congruent, these have to be congruent. All of them have to be congruent because they're all radii. Okay, so we've got some sides congruent. Can we say the included angles are congruent? Why? How? They're vertical angles. Vertical angles are congruent. Vertical angles are congruent. We have enough information to say that those two triangles are congruent. I say yes. Okay, so we need to find ways, and the reason why I show you this is because, first of all, you're going to see a couple questions in the homework like this. But we got to be ready to use other information to get those congruent sides. They're not always just going to give you, hey, these sides are congruent. You're going to have to use a midpoint. You're going to have to use maybe a circle. Okay? Probably not an actual proof yet, since we haven't really talked about circles. But you're going to have to use those things, vertical angles, right? We got to be aware of all. All right, so let's look at a couple things here. Maybe have a look out. Yeah.
Something that you with this.
Like the circle one? Probably not. No. We're gonna see some proofs for sure, but not like that one. If that wasn't actually a proof. All right. So I'm gonna look at 10 and 12 here. See if you can- And I want you to talk to somebody, do we have enough information to prove the triangle's congruent? Why or why not?
I think we do first.
Yeah. Yeah, yeah, yeah.
I would do later conference because we know that.
Something else exploded in the explosion.
Whoa.
It was open and it got over.
Super moisturized.
It was lotion.
All right, pretend, do I have enough information? Yes or no? Yes. Yes, absolutely. Those right angles are congruent, right? Right angle congruence theorem. So right angles are congruent. I've got side angle side in each of them. That's enough information. How about for 12? Yes or no? No. Somebody tell me why not? Why does this not work with our side angle side here? Okay? Yeah, we can't do that, right? It's not included. Okay, it's got to be the included angle. So if we knew that T and Q were congruent, that would be enough information. This is not enough information because what we could do here, and later on in the chapter, I'll show you a demonstration of why this doesn't actually work for a side-side angle. But this, there's nothing guaranteeing that this angle is set. So we can move it closer, we can move it further away. Okay, it's not going to work. It's not going to lock us into one. So it has to be that included angle, otherwise it's not going to work. Okay. All right. Let's try one on our own here. Let's try a proof. Okay, or when I say on our own, I mean with somebody. Right? I guess you do it on your own too. But here's your information. This is very similar to what we already did. Let's see if we remember what we did. And then we'll take a look at a new one. Remember, if they give us numbers in those angles, feel free to use those numbers to label that angle. Call it angle 1, angle 2. That's going to save you some time. Try to talk to somebody about it. What are you doing? What did you do? What do you see?
Yeah, well.
Great. Here we go. So they give us, and again, this is very similar, almost the exact same thing as the other one that we did. They tell us that those sides are congruent in the given. Okay, what else can we say here? Riley?
C, like line CA and line AC are congruent
Okay, what's the reason?
because of the reflection.
Reflexive property. Okay, so I've got those two sides. What else do I need to say here? And why? Go AIA, because we know these are parallel, forms that Z shape. AIA, that's enough. Say side angle side. Next.
Do you have to put the parallel?
You would have to, in your proof, say they're parallel because it's part of the given and we used it. Yeah. So that would have to be one of those steps. Right?
Triangle ABC.
What's the reason? There you go. That's it. Reason should be easy today because we only have one, right? Once we get into more of those letters, as you can see on the I can statements, right, you see some of the other ones that we have. Becomes a little more tricky, right? Trying to figure out what information we need. Now we know, for today, we know exactly what we need. We need two pairs of congruent sides and an included angle. Okay. All right. Got two small things here, last things. I want you to look at 14. And this is another one of those, do we have enough information? Questions. Okay, I want you to talk to somebody. Do we have enough information for 14?
Oh, yeah. So I think it's like the same as like what we've been doing. Yeah. Oh, yeah.
So reflexive property, right? We can say KM and K. We know that. So we got two pairs of sides. Do we have enough information to say an angle? Let me rephrase that. We have enough information to say an angle. A pair of angles are congruent because we got parallel lines. It's just a matter of, is that the correct angle? Jackson, what do you think? Yeah, these are the ones that we have congruent. Okay, and this is easily confused. A lot of times people will mess this up because they see parallel lines and then they think, well, I got parallel lines, so these must be congruent. And that's not true because the Z that's formed there isn't formed using the parallel lines. Okay, when you make that Z shape for the AIA, it has to contain the parallel lines. So this is the Z shape that we're forming right here. So these two angles are congruent and those are not the included angles. So we do not have enough information on this one. And we got to be careful of that. I see it all the time where people try to say that these two angles are congruent just because we have parallel lines. Now, if they told us KL and NM were parallel, then yeah, then we would have enough information because then our Z would put us here and that would be included. We don't have that. Okay. All right. I'm not going to have you write out this last proof, but I do want you to discuss it with somebody. Okay, so just talk it through. I'll give you 2 minutes. Talk it through. How would I get those two triangles to be congruent here? All right, so we have two pairs of sides already, right? We have two pairs of sides congruent. We can get an angle. How can we get an angle? Here, Ethan? Vertical angles. Okay, we got vertical angles and angles across from each other. Really, what it comes down to is, are we paying attention to which triangles we're trying to prove? Okay, because you could very easily do the same exact proof and be proving that these two triangles are congruent. But that's not what it's asking for. It's asking for the top and the bottom. So when you see a figure like this, there are a lot of different triangles within this figure. Okay. Eventually, sometimes they might ask you to prove a couple of the big triangles are congruent. not yet, but eventually. Okay, they might ask the small ones. So we need to really hone in on what triangles they're talking about. If you need to sketch it out and highlight it or make sure we know exactly which triangles we're trying to prove. So we've got our givens here, 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 and here, and then vertical angles. That would be enough for SAS. All right. Just make sure that we're naming those angles correctly, like PTQ and RTS. We gotta name those correctly. Any questions about SAS here? Okay, go ahead.